right. So we were looking at some of the limitations of interacting with MongoDB at the command line. For instance, the positional operator. We saw that it cannot nest more than so many levels, and certainly some of that manipulation of those data structures would be much better done at a programmatic level. Right? So instead of using direct manipulation, we would perhaps manipulate the data in JavaScript, perhaps, right, and then just store it back the way we want it stored into the database. So to that end, we're going to be looking at being able to interact with Mongo and non-relational databases using libraries, right, or some programmatic infrastructure that allows us to do this programmatically. Mongoose is one of several libraries that allow you to interact with MongoDB programmatically, and it gives some of the things that we lost in Mongo as such as no support for schemas and validation and joins, all that a lot of those things that we lost in Mongo are actually back here in Mongoose. Right, so a lot of the things that we cannot do are not supported by the database itself. Right, we're going to be shifting a lot of those responsibilities that used to be part of the databases, right, are now going to be shifted over to the application layer. Right, so Mongoose is one of those libraries that allows us to do that. Mongoose, it's you can visit the website at Mongoose. There it is, Mongoose. Not that Mongoose. No, not that one. It's not a bicycle. I used to own one of those. Is it Mongoose.js, I think? Yeah, Mongoose for MongoDB. There we go. So this is the official website, and you can install it using npm. So npm. So all these libraries, right, are going to need for us to be able to execute JavaScript, right? A code that is written in JavaScript running on our desktop, right? Typically, we think of JavaScript as being the web, the programming language for the web, but JavaScript has really exploded and become a really force to contend with. It looks like it's finding its way everywhere these days. It took over the browser. It looks like it's taking over the middle tier and it's taking over the database as well. So anyway, so this is a library that can embed or can participate in as a module in a Node.js infrastructure. Node.js is just a compiler. Well, not a compiler, an interpreter that can execute JavaScript on a desktop, right? So to be able to use Mongoose, you'll need to install Node.js. Node.js is available at nodejs.org. The latest version is version 11. So you should install Node.js. And also install Mongoose. We'll show you how to do that in a minute. Okay. All right. So let's see how we can talk to MongoDB using JavaScript. All right, so to do that, we're going to first create a directory where we can build some Node.js applications to interact with MongoDB. To do that, we're going to create a directory. Let's see. Let's do this in a separate tab. Not here. Maybe here. There we go. That's whiteboard. Blah blah blah. I don't think I'm going to be doing that. Let's go back to CS 5200. Let's go into 2018. Let's go into fall. And let's go section 2. And let's create a new a new project. So since we're working with the whiteboard database, we'll create a project of the same name. So we'll create a directory, make directory. I think it was called whiteboard. Was it fall 2018? Section 2. And we'll call it Mongoose. Well, I'll just keep it like that. Let's go in there. And we're going to initialize the project using npm. So when you install Node.js, it'll have two executables of interest. One of them is, one of the executables allows you to execute just plain old JavaScript. Right? Typically JavaScript on the browser is the one who executes JavaScript. Here, you need an actual executable. Right? You need somebody who can interpret the JavaScript and run it. That executable is called Node. When you install Node.js, you get a command line like Node here, and then you can go into a command line interpreter and execute JavaScript. The other command of interest is npm. npm allows you to install new libraries. It's very much like when you do in Java, you do a Maven clean install. Maven is a package manager, allows you to install new packages. So npm is kind of like the equivalent of that, right? That allows you to install new packages, manage projects. So one of the things that npm can do is initialize a project, right? Such as npm init. And this will go through several questions. What's the name of the package of the project, the version of the project, any descriptions, entry point, if this lives on Git, the author, and licensing, and what it does, it just creates for us, it creates a package.json file that the only thing it is that it describes our project and any dependencies our project has. It's very, very similar to the pom.xml file that we've seen in our Java projects. Okay, if you remember, the pom file declares dependencies, such as saying that your project depends on JPA, that it depends on a MySQL database, that it needs these libraries, right? And then to install all these things, you say, Maven clean install. So very similar here, very, very similar. In our case, for instance, you might do npm install. Very similar to Maven clean install, right? Same thing here. All right, what else? One of the things we might want to install is the Mongoose library. We're gonna say our project needs to talk to a database, the Mongo database, and we want to use the Mongoose library to do that. So we can do npm install and then Mongoose. That's going to go fetch the libraries from a central repository and download the libraries and install them locally. And it's going to put them in a particular directory. Right now the only thing we have here is package.json. But if we install Mongoose and do a -- save, it's going to start downloading Mongoose. It's going to copy it into a local directory. The directory, can't type. The directory is called node_modules. See that? _module. That's where all the libraries are stored locally. You can store globally, or you can install them locally for this particular project that we have here. Okay, so we can see that the content of node modules. We say node modules, and Mongoose should be right there. Mongoose. There we go. Mongoose is there. Okay, so we have Mongoose already installed here. Very good. The -- save that we use there, the -- save, what it does is that it makes an entry into the properties file that we have here. So we have we'll look at more package.json here. You'll notice that now it has a dependency entry in the package.json there. See that? Saying that this particular project depends on Mongoose, the latest version of Mongoose 5.3. This is identical to what the pom file does. Right? The POM file has a dependencies set of elements, right? And in there, typically we list things such as JPA, we list things such as the MySQL database connector, things like that, right? And then when you type maybe install, it downloads all those files and it stores them in a particular directory locally. All right, excellent. So we have that. Let's keep going. Let's open up this our project with our favorite IDE. Let me close this up. Let me close this project and let's open up another project. Let's open up the project we just created. Let's see, under CS5200, 2018, fall, section 2. There it is. Let me open that up. All right, excellent. So let's create a couple things here. First, we're going to create a file where we're going to encapsulate the connection to our database. Right? If you visit Mongoose, Mongoose will give you a clue on how to get started, right? On how to load the Mongoose library, how to connect to a local database, and how to immediately start talking to collections that might be stored already in the database. Okay, so let's do that. So instead of doing this anywhere we want, we're going to encapsulate this type of code in a specific file, right? That we can then invoke it at any time that we want to connect to a database, right? So to do that, we're going to create a DB directory. A data directory, and in db.json with JavaScript, we're gonna add this code in here. So let's create a data directory in here. So we'll say create a data directory, data, and in here we're going to create a JavaScript file. So db.javascript, and in here we're just going to copy this, and let's look at it of what this says. All right. So what we have here is a couple of lines of code, and the code is embedded inside of a function. See that? Right. This function in JavaScript, functions can be treated as plain old functions, but they can also be used as constructors, as if it were a class, and you can instantiate instances. Right. So this function here is playing the role of a constructor, right? That can instantiate an instance of this class. Here, module.export, that is the equivalent of creating a module, a self-contained module that can then be loaded by other folks, right? Very much like in Java, you would say import or include in C# or in C, right? So that you can create small modules that can then be built and loaded by other folks. So export allows you to export a particular function, a particular variable, a particular whatever, so that other folks can load whatever's in here. Make sense? So that's what module.export does. Just makes this available elsewhere. What we have here is the first line of code is that it's going to require. Require is the equivalent of an include or an import, meaning find me a library of this name and make it available in a local variable called Mongoose. Right? Then here I'm just declaring a variable, the name of the database. I forget what the name of the database was. Let's see. Show DBs. I think it was this one, right? So let's copy that. So that's the name of the database. So let's replace this with the actual name of the database. And then we're going to create a connection string, meaning the URL of where the database is running. So it's running localhost in my local machine, and we're going to concatenate the name of the database so that we can connect to that particular database. Yes? And to connect to it, we're just going to do mongoose.connect and the connection string. That's it. This connects us to the database. All right? If it exists. All right, excellent. So we've encapsulated the functionality of connecting to a database. Let's keep going. Now that we have that, we want to connect to or interact with certain collections in that database. Let's look at the collections that we have. Let's see. We have show collections. We have course, courses, section, user. Let's look at the user that we have here. We can say db.user.find dot pretty. Let's see if we can think of look at if there's a pattern to the data that we have stored in here. So we have let's see, Ada, we have Alice, we have T. Lee, John, Jane. So it looks like we have a username. Looks like we have a first name, last name. We have a type. We have an office. We might have a GPA. We might have a first, but this was an error. Right? This was an error. We didn't mean to actually do that. So let's ignore this here. So let's create a schema, right? You know, the things that we could not do in Mongo. We can actually do it now using this high-level library, right? Create an actual schema, right? So what we're going to do is that we're not going to burden the database with validating schema. Instead, it's going to be handled at the application level. So let's create our own schema. So to do that, in the data directory, we're going to create another directory called models. And in that models, we're going to do everything that has to do with interacting with particular schemas, particular collections. So let's create a user schema in here. New JavaScript. There it is. So here we're gonna create a schema that describes each one of the records or collections that documents that are stored in that collection. Right. So let's describe it. Here, copy. I'm gonna paste that, and let's look at it for a second. This is again, it's gonna load the Mongoose library. It's the Mongoose library has a function called schema that, as you might have guessed, it allows us to create an instance of a schema, right, at the application level. This has nothing to do what's going to do what happens in the database, right? This is all at the application level, right? And takes as argument a JSON object that allows us to describe the structure of the data, right? We say that all our users are going to follow the following pattern. They're all going to have a username, they're all going to have a password, a first name, a last name, and we're going to add a couple things here. They're going to have an office, they're going to have a GPA, which is going to be a number, and what else? It's going to have a type, and it's also going to be a string. Okay, right? Where the type is an enumerated data type, right? And we could also do that. Notice that we have here strings, 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 strings. For username, password, first name, last name, it's okay if we don't set up any constraint, right? You can pretty much type anything you want for first name, anything you want for last name. For the type, we might want to maybe constrain, you know, the things that you can actually provide as valid types. Okay, so we might say that according to the database, valid types is faculty and students. So we can constrain that in here by saying that this is not just any string. We can provide an actual object that says that the type of this field is a string. So this is identical. This is identically equal to just saying string. Right? So this here is identical to doing this, but if you do it using this syntax, you can provide additional meta information. Right? Not only is this a string, but the enumeration, right, is that is going to be an array enum, enum or enums, I forget. I can remember. It would be a valid list of values that this value can take on. For instance, it can be either faculty or it could be a student. Let me look up Mongoose enumeration. I probably have an example in my enum. Okay, yeah, enum. Yeah, enum. For the numbers, you could also have, for instance, you can add additional validation, such as saying that not only the type is a number, But you can say that the minimum is 0, right, and the maximum maybe is a 4, right? So things that you could not do in the actual database, right? You can now do this kinds of validation and constraints at the application level, right? And Mongoose would validate and make sure that the database meets all these requirements. Make sense? All right, excellent. There, so we've declared the schema. Then the next thing to do is to actually create something that will allow us to actually interact with the database. Right, so we know what the structure of the data is. Now I want to talk to the database. One of the things that we can configure is the name of the actual collection that we're using to store this information in the database, right? So apparently, the name of the table or the collection is user. So it's perfect, right? We've configured it correctly. That is the name of the collection that we're talking to, that's stored in Mongo. Yes. Excellent. So let's now, in a separate directory called user DAO, you can guess what's going to be in there, right? All the CRUD operations will be implemented in a DAO. So the same pattern that we implemented in Java is also applicable in any language, right? Whether this might be PHP or whatever, right? It's a common design pattern. The common design pattern is that we don't just connect to a database wherever we want. Typically, we encapsulate it, right, and put it in one place in one single maintenance. Right, so let's create here a file called user DAO server. Right, and in here we're going to encapsulate all the things that we want to do to interact with the database. Right. So the first thing we're going to load Mongoose. Right. We're going to load the schema, the one we just created 2 seconds ago, this schema, right? We're going to load it. Oops. There's a DAO. We're going to load it, and we're going to have a local reference to it. And we're going to use another Mongoose function called model, right? .model. Right? This model is going to be the equivalent of our repositories in Java. Remember repositories? In the JPA repositories, they provide some generic functions such as find all, right? Find by ID, right? What else? .save. Remember those, right? So the JPA provides some generic functions. You just need to configure it. You need to configure what am I storing? What am I retrieving? And you need to give it the class of the entity file, yes, and you need to give it the primary key. Here is a slightly different. Here you have to give it a unique identifier, right? And this identifier is whatever you want as long as it's unique, right? And the name here will have meaning later on. This name should be a well-known name in your application, right? All developers should agree on this very important name, right? It should be meaningful, okay? Because it's going to be used later to do things such as joining, right? And again, the database doesn't support, but the application, right? These libraries provide pseudo support for things that look like joins, but they're not really joins, okay? The other thing is it takes as argument is what are you storing? What are you saving? What are you retrieving? What are you reading? What are you updating? What are you deleting? I'm deleting instances of users, right? They all have the structure of usernames, first name, last names, things like that. It needs to know the schema of what it is that it's storing and retrieving. Make sense? Okay. Right. Now we have that. We can expose and maybe export it so that folks could use it outside of this file, right? Let's keep going. So what things would we implement in here? Let's try it out. Let's play around with our newfound powers. Let's create a test file, right, in our data here. Maybe have here test.js. And in here, we're going to use the DB to connect to the database first. Right, so this require is going to load what? Remember the DB, where is it? Oops, I think it's that. Oh, okay, sorry. The test is up here. I'm going to move it here. There it is. Okay, there we go. So it's going to go into the DB. Notice that it returns a function. See that? It returns a function. So this require here is a function. And notice that I'm calling that function. So I'm executing that function. That execution of that function will connect to the database. Where we'll run whatever's in here, which will connect to the database and to that particular database instance. Okay? After it connects, we're going to load the model. We're going to load the model, the DAO. I guess a better name would be DAO. Okay. Maybe DAO might be a better name. So basically whatever this returns, and this returns this user model here, right? This object right there. Once we have that, basically this allows us to do some very generic operations on this, right? So for instance, one of the things that we could do is do a find. Right? The find is identical to the find you would type at the console, right? That it basically returns all the elements from a collection. So let's do that. There it is, DAO. Why are you complaining? Or probably the version of JavaScript is complaining here. Preferences, languages, JavaScript, latest version of JavaScript. Say OK. OK, there we go. So this find method, now this find method is a little bit different than what happens in Java. In Java, the connection to the database is synchronous, right? If you remember, when you do a find all or find by ID in Java, whatever it returns from that function is then assigned to a local variable. Yes? Right? That means that call is synchronous. Meaning that even though it needs to connect to a remote server, right, the thread that is running blocks, waiting for that connection to occur, and retrieve all the results, right, instantiate all that into memory, and then assign it to the variable. Meanwhile, the thread is blocked. Make sense? So that's what we mean by synchronous. It waits until the call comes back from the server. Here in Mongo, by default, the calls are asynchronous, right? Meaning that these functions don't wait for the server connection to go out to the database and come back. Right? Instead, if you had here console.log done, okay, this function here, this function call would not block and wait for the results to come back from the database. It would just immediately continue to the next line. So it would immediately then print done, right? Even though the results might not have yet come back from the database. It's asynchronous. Make sense? That's very important. That's very important that coding things asynchronously is much more complicated than coding things that are synchronous, right? It's non-trivial. So anyway, so the default way of implementing this is that you provide, as an argument to the find function, you provide a callback function, meaning this function will be invoked at some later time in the future whenever the response actually comes back from the database. Right? When eventually the database responds, right, with the result set, right, this function will be invoked, right, notifying you that the response came back. And then you can do whatever you want with that response. We are just going to display it in the console. That's all we're going to be doing, right? So this function takes two arguments. The first argument is error. Has anything happened? Anything wrong happened with the database? Lost connection, or maybe a syntax error, or anything, or timeout. Okay. The second argument is presumably the result set, right? Whatever comes back from the database, right? Hopefully some data, and typically will be an array of documents that come back that met your criteria, whatever criteria you might have passed in. And then that function is called, and then here's the body of the function. The body of the function is a very trivial one. It just prints out whatever comes back from the database. Okay? All right, let's try it out. We can try it from the command line. Let's see what we have here. That's MongoD. I don't want to do that. Here, I believe this is where we want to be. We have data. Let's go into data. There's our test. We can run test.js. Let's see if this can complain. And notice it worked. Right? It went out to a database, came back, and indeed, these are all our users. Right? We have username, ADA, right? And everything came back from the database. Right? As an array, as a plain all array. Everybody good? Everybody still with me? All right, excellent. So we can connect to the database. Let's keep going. Now, typically, what we like to be able to do in a DAO is not really use these low-level functions, right? We don't really want to use these low-level generic functions. Typically, what the DAO does, right? All the DAOs that we built in Java, they provide some high-level API, right? That hides the low-level idiosyncrasies of whatever infrastructure you're actually using, right? Whatever database vendor you might be using. Right? So it provides a high-level API to the rest of the application, so they don't have to deal with the idiosyncrasies of whether you're using Mongo or you're using SQL or using whatever particular vendor you're using. Yes? Right? So that's exactly what we like to be able to do. Instead of using these low-level functions, ideally, the DAO would implement these kinds of functions. These types of callbacks here would be implemented down under in the bowels of the DAO. Okay, so here we would provide functions such as find all users. So that's a high-level function, as opposed to just a generic find, right? So this function might look something like this. There it is. So find all users. It's just basically a function. And actually, I don't need that. Actually, this is a ES6. It has a very sparse syntax, which some folks don't find it very intuitive. So basically, this is a body, and I'm doing a return. It's just a function with no arguments, and it runs. This is the equivalent of typing something like this, function. Okay, this is the old school way of writing functions in JavaScript. In the new version of JavaScript, they've made an effort to make it very sparse, right? So that you have to type less. A good programmer is a lazy programmer. And if your function, the only thing that it does is return, right? You don't even need that. You can just remove the curly brackets, and the return is implied. Make sense? All right, so we're just returning. We're just returning that user model.find. Okay? Everybody okay? All right, excellent. So basically, I'm using the low-level find here, right? And I've wrapped it with this higher level API that has a little bit more it's much more descriptive, yes, of what is it ideally what we're returning, right? And what we're going to export is we're not going to export this low-level model. We're not going to export this low-level model which has low-level functions. Instead, we're going to export this higher-level map that has all our API, all the functions that can be called from outside of this module, right? This find all users. So now Now our test will look a little bit more nicer. It'll be user DAO dot find all users. Okay, we can call this higher level function, find all users. Now, we still have to deal with the fact that this is asynchronous. Right, that this is not a synchronous call, it's an asynchronous call. Right, so somehow we need to register some callback function telling us that, hey, I'm back, here's the data that you were asked for, there it is. Right, so to do that, the API to handle these asynchronous call is a new idea that allows us to treat asynchronous calls as if they were synchronous, okay, which is not a simple idea. The problem with asynchronous calls is that asynchronous calls by design or one of the side effects of having asynchronous calls is that they are not necessarily executed in any particular order, right? You can send an asynchronous call to a server, and you don't know when it's going to come back, right? And if you can send multiple asynchronous calls to a server, and they could come back in any order, right? Not necessarily in the original order that you sent them, right? So somehow you need to, if your logic depends that things occur in a particular order, somehow you need to synchronize all these calls. Yes, right? So it's not a trivial thing to do. One of the ideas of trying to synchronize all these calls being thrown all the way across a network is to use a concept called promises. A promise, okay? Meaning, I'm going to promise you that at some point in the future, I'm going to notify you that this was successful. Right? You just need to let me know how you want me to notify you, right? So we're gonna loosely couple between these two processes, and I'm going to send you a message when I'm done. You just need to tell me how. So basically, what this find method returns, right? It's not actually the data. It returns a promise to at some point in the near future, hopefully, that I will let you know what the data is. Right, so the return of this is a promise. And that promise, that's what this function returns. That promise object has a function that is attached to it that allows us to provide a callback function, register a callback that at some point it will be invoked. Okay, so here, hopefully at some point the users will come back and I will be able to print them in the console. .log users. Okay. Now these can be written easier to read in this way. There it is. That's easier to read. That makes sense, right? So this returns a promise, and the promise has a function that allows us to register a function, which will be called at some point in the future with the actual data. All right. Okay. So let's try it out. Let's see. Let me run that again. Okay, it works identical to before, right? But it's a little bit higher level than we had earlier. All right, excellent. So we have find all users. Let's implement a couple more. Let's see. Okay, so we did find all users. We did that. How about find user by ID? That's another one. That's very common. All right, so let's go into our DAO, and we might want to find a user by a specific user ID. Notice that it takes as argument a single argument, user ID, and it uses that as part of an argument to the find function. Right? Notice that it says here's the criteria of the search. See that? It says I don't want all the users. I only want the users whose underscore ID is equal to user ID. See that? Very much like what we would type at the command line, right? .find, right? And then the criteria. Yes? Right? And what does it return? Again, it will return a promise. and we're going to expose this as part of our API. Right, we're going to comment that out for a second. And now we're going to try this out. We're going to say user DAO dot find user by ID. Then hopefully this will be a user object. And we're going to just console.log the user. Right? So let's go. This takes as argument a string of some user ID that I want to fetch. Let's go fetch a user here. Let's look. Let's retrieve Ada. That's the ID for Ada, and we can pass it as an argument. There it is, and let's rerun this. Okay, there it is. There's Ada. There's Ada that came back with only that object. Okay. Also notice here that it came back with an array. See that? It came back as an array, even though we know we pass a primary key. Right? We pass a primary, so we know there's only one of these objects. So we should be able to fix this function. We should be able to fix this function by saying, you know what, this find function would be nice that knowing that this is a primary key, it would actually return that one single instance. And actually there's a function here, retrieving a single unique identifier, returning a single instance is such a common use case that there's a syntactic sugar version here of user model. Instead of .find, there is a find by ID that you can pass in just a user ID, which knows that it maps to the underscore ID equal to that whatever you pass in as an argument, right? And since it knows that it's a primary key, it knows that it can unwrap the array and return the single element. Okay, so let's try that again. Okay, notice that now it actually returned just the object instead of an array. Make sense? Okay. All right, so let's go on and implement another one. If, for instance, find user by ID, we just did that. How about by username? Find by username. So we would implement something like this. Again, it would be equal. Oops, so this is missing an equal here. Equal. Oops. There we go. So find user by ID takes as argument a username and uses a user model to do a dot find where the username is equal to that username. Okay. And if we try it out, let's play around with it. Let's comment that out and do a. Oh, we'll need to expose this in the API. There we go. So we can say user DAO dot find user by username, and we'll pass in as argument Ada's username. There it is. So Ada. Yeah, there we go. And we're going to do a dot find then user and then just print it out. So we'll just copy this. Okay. All right. Let's try it out. Okay, notice that again, it's an array, right? Because the dot find always returns an array, even if it's just one element. Okay, so we also have syntactic sugar when we know that whatever we're passing you, we know it's a unique identifier. There's only one of these, but it's not a primary key, so we can't use dot find by ID. That only works with primary keys. So this one has another version where we know there's only one of them. So find one. Find one. We know it's just one of them, right? So whatever comes back, just return to me the first elements in that. If it's an array, it just returns the first element. So we can try that again. And again, it just returns the object that came back from there. Everybody good? It's just syntactic sugar, right? So just for convenient purposes. Find user by ID using find one. All right, so let's take a look at insert, update, and delete.